Hey guys, Mark Schuyler here. I'm with Westy Travels, but today the Westy is in the garage. I've taken a lot of the parts that I've had in the Westphalia over the years and have been gradually upgrading. But I didn't know what to do with the old parts, so they were languishing in the workshop. And I finally said, you know what? Let me build a little energy cart out of all these little leftover parts. So I call it my Frankenstein energy cart. It has like Victor Frankenstein's monster. It has a little of this. It has a little of that. Let me show it to you. Here we go. So you can see it's on a dolly. I've got it on a little like a cart here. And the cart was one that I'd actually had to weld a broken piece back onto. It was sturdy enough, but I just as soon dedicate it to this purpose than have it around for moving anything. So a little piece of oak laminated plywood, and which I actually did have to buy, and I trimmed it down to size just a little bit. But almost everything else that you see here is something that's been retired 8 years ago or so, as I've slowly upgraded. For example, let's go to the heart of the system here. These batteries are Go Westy batteries, 50 amps a piece. I have them wired in parallel, 100 amp hour total. And they were okay in the van, but when I could, I upgraded to some Battleborn Lithium, and you know, it's just the bomb. It's just awesome. And so these were close enough in age that I could put them together successfully. And the inverter is monstrous. It's just huge. Look at the size of this thing. And the inverter I now have in the van is less than 50% this size. And they're both pure sine wave inverters. But the one I have in there now is less than 50% the size, as I said, but it's also got 2,000 watts of inverter power compared to just the 1500 here. I was surprised. I went online to see what these things were selling for, and they're still selling for a lot of money. I don't know quite if anybody knows why they're selling still for, you know, $500, $600, $700. If those people are crazy, or if there's something about these that are just awesome despite the size. You can see that the inverter came with this massive fuse, and this is the original wiring from it. It's 2-gauge wiring, and I've also used the 2-gauge wiring for wiring the batteries together in parallel. So let's take a look at the AC to DC charger. We have two ways of charging. We can either, you know, take it right from the wall, assuming there's power before the storm, just top off the battery, make sure everything is ready to go if we have an outage. But we can also charge with solar. I have solar outside. I can run this at least 50 feet of wire out there and start using this older solar charge controller to top off the batteries. You can see right now they're fully charged, 13.3 volts, and I made sure to balance the batteries before doing anything. The downside on this compared to the solar charge controllers I'm running in the van now is I'm running the MPPT charge controllers, which are just more efficient, better in cloudy weather. This is the older PWM, pulse width modulation. Yeah, PWM, pulse width modulation. But they're a lot cheaper. They're super solid and stable and known technology. They're pretty tough. So, you know, it's not like I've just thrown that away, and it's going to be great for this application. So let's see. I'm trying to remember what the MPPT stands for. It is maximum power point tracking. Yeah. So, but they're much more expensive. They're at least double the price of these. But again, for my primary use, the van gets what the van gets, and what it wants, it gets. But this was a great use of older material that was just languishing in the workshop. This, as I may have mentioned, was the only thing I had to actually go out and buy, because I did want a way, besides through solar, to be able to feed energy to these batteries. So let's see, what else can I tell you? On the back, I have a little extension cord here with a little splitter. And the reason this is important is on the side of the inverter, I only have two GFC receptacles here. That's it, just two. That's not enough. So I am going to use that tiny little splitter there. I'm going to be very careful to keep minimum loads on there. I can already hear people saying, you're not supposed to do that, just use the two. But if I just use those two, I'm going to have the modem, the DSL modem we use to stay connected to the internet, and the wireless router. And that's about it running out of this whole energy cart. How do we charge our other devices, keep our phones and computers charged up? How do we even run the fan so that this fireplace works a lot better? There's a little fan hiding under here. I have to clean that up a little. But you can see that I can even plug in there so that we get so much more heat thrown from this fireplace. I have also on the back, kept all the manuals for the solar charge controller, for the inverter, for the AC/DC charger. Really wasn't any material from Go Westy on the batteries. Not that I recall, not that I kept. But if I ever need to consult with anything, I still have that material. It was a fun project. And like with Victor Frankenstein's nameless monster, it's just made up of scrap parts from this and that, but better than it just sitting gathering dust, and I can get some use out of it. I realize it's only got a couple days worth of juice before I had better get some more in there through the solar or somehow through the AC. But at least we got that couple days, and it was just fun to build, work with all the crimping and the cutting and the planning. I will come up with a wiring diagram, simple as this is. I always like to have a little wiring diagram. And if you're interested, you could see all the size of the wires and the compression lugs and everything that I used. So yeah, go do it. Make one of these for yourself if, like me, you've been gathering up these extra parts and you don't really have to buy much to complete the system. Thanks, guys.